AP Calculus students. Today we are working out some problems on the Chapter 2 test review. Remembering that the test has been canceled due to our new remote situation, but it is worth a quiz grade. So there are some problems, 1, 2, 3, 4, 5 problems that I think because they have graphs that they're best done in this manner instead of trying them on a big whiteboard or on my writing tablet. So let's go ahead and cover some of these problems. The first one I'm doing is 2MCA8, and the picture looks like this. And the question is the graph of the derivative of f. So I'm going to circle that right now because we are so used to graphs of f, and this in fact is a derivative graph, and you should stop right now and tell yourself that that would mean on this graph where x is 2, that there is some function whose derivative is 5. This is not f of 2 equals 5. This is, there is some function at x equals 2, its derivative is 5. This is some function at x equals 0 and its derivative is 2. Let's continue reading. The points 2, 6, and 4, 18 are on the graph of f, right? Notice 2, 6 is not on this graph and neither is 4, 18. That's because they are on the graph of f, not the derivative graph. Which of the following is an equation of the line tangent? Stop right there. Let's write the equation of a tangent line. To the graph of the original function that we are not given at x equals 2. Okay, notice I have marked this problem up a lot. That is what you should do when you're reading a problem. Mark it up to help yourself out. Okay, first of all, normally what's easiest for us is to put the point in, right? So what they told me is that my x is 2. So I'm going to put that right here. Where do I get the value of the function at 2 from? They gave it to me right here. They told me on the function for the point 2 that its value is 6. So we now have 6 plus the derivative of the graph at 2 times x minus 2. Now you can see why right here, why they gave you the derivative graph of f. Right, so here's 6 plus the derivative of f at 2. I look at this graph here, because that is what it is a graph of, is 5, x minus 2. So notice the slope is 5, so now it's either the third or the second or the third answer. When I distribute here, I get a negative 10 plus 4, so the answer must be y equals 5x minus 4. Next, we're going to do the next problem, 2MCA9. It is also a graph. Notice it says that this is the graph of f, of an actual function. The graph of the trigonometric function f is shown above for x between and including a and b. I do see that. At which of the following points on the graph could the instantaneous rate of change, that's a derivative, that's the slope of a tangent line, equal the average rate of change of f on the interval AB? Let's underline this in blue. The average rate of change of f on the interval from A to B. What does that look like? Well, it looks like this. The average rate of change would be, here is f of A here, right? Here is f of B here, right? If I drew this line from A to B, right, the slope of that line would be the average rate of change from of this function from A to B, right? That's what the slope of the line represents. If I connect those 2 points. So let's take a look. I'm going to help myself out. I've got a little ruler here, and I'm just going to connect these 2 points. And this slope would be the average rate of change over the interval. F of B minus F of A, F of B minus F of A over B minus A. So, which of the following points, A, B, or C, if I drew the slope of the tangent line there, which would represent the derivative, would have the same slope as the one I see? Well, let's take a look at A. No, that's not it. At B, yeah, I think it's at B, right? It's not at C, right? C is definitely not that slope, and it's not at D. So I would say if I drew a tangent line at B, it would be B. Notice I marked this problem up a lot for myself. Let's look at 2MC B5. Here we go. 2MC B5. Okay. This one is a very interesting question. Okay. Let G be the function given by. Okay, and we have this limit here. It's written pretty small, but gosh, this looks familiar to me. This looks to me like the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Notice that this is the limit definition of a derivative of a function, of that function right there. This is the limit definition of a derivative of f of x. Remember how we used to do this problem the hard way, right? I actually put in those delta x's. So notice delta x here, here, and here, if I just put in an h instead, then we have the exact same difference quotient going on. It is asking for what is the instantaneous rate of change of g. They just asked us for the derivative of g, the instantaneous rate of g with respect to x at x equals pi over 3. In other words, they're asking us for the derivative of g, so we will take the derivative of this expression. Well, this is interesting because it seems like it's a derivative on the inside, and we're taking the derivative of that. So it never says it, but it really is a second derivative. So they will have this expression, something like this expression, on the AP exam every time. Okay, now let's just take a look on the inside here. On the inside in parentheses, we have decided that there's really no math to be done, calculus, that we know what this is. This is the limit definition of the derivative of this function on the top of the numerator on the right. So essentially, on the inside, all they're asking us for is the derivative of sine. I'm going to point that. So what they're really asking us for is the derivative of sine. So rather than using this difficult limit, I know what the derivative of sine is. It's cosine. And I know what to do with this. So here's what we're going to do in green. The derivative of g equals the derivative of sine of x, and that's on the inside, and I'm taking the derivative of that, and then I'll evaluate it at x equals pi over 3. Okay, first of all, the derivative of sine is cosine. So now that's the inside. Now I'll take the second derivative. That would be a negative sine, and I'm going to evaluate that at pi over 3. Well, sine of pi over 3 is square root of 3 over 2, and it's negative, and that's how the answer is the first one, negative square root of 3 over 2. But that's pretty weird. Most students won't get that. But you'll see one of those on the AP exam, and I wanted to make sure you saw it here, because if we keep doing it, you will be the kids who get it right. Okay, let's take a look at 2MCB7. Oh, that's the next problem. Excellent. This is a typical problem on the AP exam. I'd call this a level 4 maybe, 3.5 or 4. Okay. The function f is given by this function. Oh Lord, there's a b in there. Oh Lord, is being multiplied by g of x, right? Where b is a constant and g is a differentiable function. I'm gonna circle that. That might be important to me. Satisfying g of 2 is 3 and the derivative of g at 2 equals -1. For what value of b, right, helping myself out here, is the derivative of f at 2 equals 0? This is what they're asking us for. Okay, notice they gave us this function f. They're asking us for the derivative. They're telling us that at 2 it has a derivative of 0. Okay, well, the first thing I have to do then is take the derivative, right? So here is the derivative of this function. Notice it's a product. Here's x cubed plus bx plus 6 is my first function. G of x is my second function. I'm going to write the product rule, okay? Well, actually, I'm just going to go ahead and do it. There we go. The derivative of the first function is 3x squared. Remember, this b is a constant, right? So if it were 3x should tell me 3, right? So plus b is the derivative of the first function times g, plus I'm going to keep my first function and multiply by the derivative of the second function. Okay, they're asking us for what value b is the derivative of f at 2, 0. Okay, so let's put in a 2 for all of our x's and let's set it equal to 0, right? So the derivative of f at 2 equals, so wherever I see an x, I'm going to put in a 2. So this would be 12 plus b. There we go. G of 2 right here. G of 2, oh, they gave that to me. Now you can see why they gave it to you, is 3. At this moment, you know you're on the right track when you're like, oh, that's why they gave it to me. Plus, I'm going to put a 2 here, and that would be an 8 plus 6 is 14. Plus, I'm going to put a 2 right here, 2b. Hopefully that's okay with you. There we go. The derivative of g at 2, oh, they gave me that. That's a -1. And they want to know at what b is this 0. Okay, let's take a look here. I'm going to distribute the 3. I have 36 plus 3b. And then this is a -1, so minus 14 minus 2b. Minus 14 minus 2b equals 0. Okay, this is looking nicer. 36 minus 14, that's a 22. Plus 3b minus 2b is a b, equals 0. Oh, well, I can tell by looking at this that b would have to be the additive inverse 22, -22. There we go. Let's see, 3MC, I put an 18. Am I missing a letter there? I don't think so. Let's see, 3MC 18. Here we go. All right. This says, let y equals f of x be twice differentiable. That means you can take the derivative twice, such that f of 1 equals 3, and the derivative of y with respect to x, that's a y prime, is this expression here. What is the value of the second derivative at x equals 1? Okay, so this is the derivative of the derivative, right? So we are going to be taking the derivative of this derivative right here and inputting an x equals 1. Okay, so let's go ahead and do that. Before I do that, I'm going to write this first derivative, and I'm just going to show that it's to the 1/2 power, because obviously I'm going to have to use the power rule. Okay, let's take the derivative of both sides, right? That'll be the second derivative. There we go. And they write it this way. Notice this is also y double prime. Okay. It equals, I'm just going to bring my 4 along. I have a composed function. I'm first going to take the derivative of anything to the 1/2 power, which is 1/2 times anything to the negative 1/2. So I'm going to put that in the denominator to a positive 1/2. So let's look at that again. Here's my 4. The derivative of anything to the 1/2, I bring the 1/2 out front, reduce the exponent by 1, which is a negative 1/2, and keep my inside function. Okay, times, I have to take the derivative of the inside function. That would be the derivative of y squared would be 2y times y prime plus 14x. Because there's 2 terms here, I think it's best if I use parentheses. Okay, now here's the problem here. I can fill in my x's and my y's with a 1 and a 3, right? They gave me that information right here. But I have this y prime here, right? And I can't have it, right? I don't have y prime. Well, I do. It's right here. So let's rewrite this again, trying to save some room here. The second derivative is equal to, let's see, I might as well do some simplifying. This is 2, cancels out, and leaves a 2 here. So let's see, I have a 2 over y squared plus 7x squared to the 1/2 times 2y, and all I'm doing is substituting right here, times 4 times the square root of y squared plus 7x squared plus 14x. There we go. Okay, now my second derivative only has x's and y's. So wherever I see a y, I will put, oh, I was pressing too hard. Wherever I see a y, I will put in a 3. Wherever I see a 1, I will put in an x. I am going to assume from there you can do your math carefully and correctly. I'm going to put a 3 in for this y. I'm going to put a 1 in for that x. Don't forget about the square root. I'm going to put a 3 in for this y, a 3 for this y, a 1 for this y. By the way, notice, this would be 9 plus 7, 16, square root of 16. Notice how nice it comes out. That's how you know you're on the right track. And we'll put a 1 in for this x, right? And then I believe we end up with an answer of 55. Is that true? I don't have the key on me. Yes, I do. Let's look at the key. Right? Hold on. Hang out with me for a minute. Where's the key? The key's in the back. I'm here, people. Don't you worry. Let's see. Yes, the answer is 55. So I am assuming you can do your math very carefully from that point on. We're doing one more problem. Again, these were just easiest. Oh, right, I chose this because it's a graph. There we go. The figure above shows the graph of the derivative of f. Oh, there we go again. It's the derivative of f. That means at b, there's some function f that has this derivative, whatever that value would be, on the y-axis. The figure above shows the graph of the derivative of f at which of the 4 indicated values is the second derivative the greatest. All right, so we know the second derivative is the derivative of the derivative, okay? And we have a derivative graph here. And we also know that the derivative can be shown as the slope of a tangent line. So I'm really looking for the slope of the tangent line of the derivative graph. And that I see, and they want to know where it's the greatest. All right, let's draw ourselves little tangent lines then. And that slope will be the derivative of the derivative, which is the second derivative. Okay, here we go. Well, that's positive. Oh, this one definitely looks positive and steeper though. This one looks like 0. This one is definitely negative. So I would say the greatest is B. And it is. Have a great day.